This video is on acid rain and acid deposition. First, we need to discuss the difference between regular rain and acid rain. Rain is naturally acidic. It is normally lower than a 7 on the pH scale. This is due to all of the carbon dioxide that animals, like humans, breathe out. Okay, so that carbon dioxide reacts with the water in the air, making carbonic acid. Carbonic acid, the most acidic or the lowest pH it can have is a 5.6. So any rainwater that is between 7 and 5.6 is just normal rain. It's just slightly acidic. If it's lower than a 5.6, that's when we call it acid rain. What makes it lower is sulfur oxides and nitrogen oxides. So this deposition is just any of the processes where acid components are present. This deposition can be wet, meaning it's already reacted or not reacted, dissolved in water, so it's aqueous. That would be like any of your rain, snow, sleet, hail, fog, dew, any kind of wet precipitate or moisture in the air that will have any of these acidic components. Dry acid deposition would just be the particles before they've dissolved in the water. So these would be like solids like dust and smoke or other gases that are acidic. So they just haven't dissolved in the water yet to form the acids. So the sulfur oxides come from burning fossil fuels. So this would be like in our power plants where they're burning coal or oil. That's going to produce sulfur dioxide. So the solid sulfur reacts with the oxygen in the air, making sulfur dioxide. This is that dry deposition. So then when it reacts with the rainwater, dissolves in it, it forms sulfurous or sulfuric acid, depending on how much oxygen, right? Just the SO2 with the water will make sulfurous, so the H2SO3. But the SO2 could also react with more oxygen, making SO3, which then reacts with water, making sulfuric or H2SO4. The other source makes nitrogen oxides, and this is from internal combustion engines. These are like cars, trucks, planes. They burn the fuel, releasing heat energy. It causes that nitrogen and oxygen from the air to combine. So they're both gases, the N2 and the O2. They can make NO, or they could also make NO2 depending on how much oxygen is there. The nitrogen dioxide then reacts with rainwater, just like the sulfur dioxide, and can make nitrous or nitric acid, or both. The problem with this is this can break down buildings and things like that, this acid rain, but it's also really bad for our plants, our animals, and then specifically just like how does it impact our water. So ocean acidification, as more CO2 is in the air, the oceans are starting to get more acidic because about 50% of the CO2 from those combustion engines, right, that's one of the products of combustion, is dissolved in the oceans. And it's going to dissolve in just that top layer mainly near the surface. This will react with things like the shells for marine animals, right? Those shells are typically made of calcium carbonate, which we've talked about how those react with acids. So that will break them down and they either can't grow at all or are going to grow differently. It's going to change that. Another thing is it is a possible cause of the reproductive disorders that some fish are having. So with our fresh water, this is coming in like rainwater out into our lakes and rivers and streams and things, or runoff and things. Most fish can't live below a pH of 5. So some can, okay, some plants can. But if the pH gets lower than 4, it is considered dead, meaning nothing will live in there at all. The nitrates from acid rain or from our over-fertilization will cause what's called eutrophication. This is where we get so much essentially fertilizer in our waters that we have these algae blooms. And when these algae blooms come, they kind of cover the surface of the water, which then oxygen, sunlight isn't allowed to get through, so the plants and the aquatic life just aren't able to grow anymore. So this is a problem due to acid rain, but also due to the nitrates. And we talked about like fertilizers and things when we talked about the Haber-Bosch process. So acid rain, acid deposition, where it comes from, and how it impacts our water sources.